Welcome to Pax Britannica. Astronomy and Empire at the Royal Observatory Greenwich. Welcome back to Pax Britannica. I'm your host, Dr. Samuel Hume. Earlier this year, I was invited to the Royal Observatory in Greenwich to sit down for a talk with two of its curators, Senior Curator Dr Louise Devoy and the Curator of First Light, Daisy Chamberlain. Before we began, I went on a tour of the museum, and it was brilliant. The place is just chock full of history. Not just the exhibits, but the building itself. You can see how generations of astronomers and navigators built our modern understanding of time and space. And as you'll hear, their discoveries and inventions were coming as the British Empire was growing, and they were interconnected in a way that I didn't fully appreciate, until now. And yes, I got my picture taken on the Prime Meridian line, because that's just something you do. After I was shown around the observatory, we took our seats in the museum, which was amazing. I mention it in the interview itself, but we're sat next to some incredible exhibits. This was really cool, and it meant that myself, Daisy and Louise were physically gesturing and pointing at things during the discussion. Safe to say, this was not a room designed for recording audio. I gave my panellists the good microphones because they're who you actually want to hear from, but if my parts sound echoey, that's why. And with that, on with the interview. Dr. Louise Devoy and Daisy Chamberlain, thank you both so much for joining me today. I've had a really lovely tour of the Royal Observatory, and I'm so excited to talk to you both about the exhibits and the history of this building. Let's start off with Daisy, the Curator of First Light. How did you get into that?
History was always my favourite subject in school, so I always knew that I wanted to do something along those lines. And history of science, and particularly history of science and its connection to empire, was always something that I studied and was interested in, but mostly kind of from a history of medicine perspective. So I didn't really actually know very much about the observatory and its history until much later on. And so I've kind of pivoted into the kind of history of astronomy more recently, but I'm extremely lucky to work on First Light, which you've mentioned, which is the project that we're embarking on in celebration of our 350th anniversary, the founding of the Royal Observatory in 1675.
Dr. Louise Devoy, the Senior Curator here at the Royal Observatory. What brought you into history or the history of science, or what was your path?
Hi Sam. Well, for me it was a bit of a handbrake turn, I'm afraid. Ever since my early teens I'd been fascinated by space, and I had a very clear career path in my head. I was going to study astrophysics and do amazing things. And then between my third and fourth years at uni, I applied for lots of different internships, obviously applied for NASA and all the usual places. And there was a bit of a wild card. There was a chance to do an internship at the Smithsonian Institution National Air and Space Museum in Washington, D.C. If you ever get the chance to go, do, because it's fabulous. So I got the chance, I went there for a summer and absolutely loved it. And it just really made me think about the history of astronomy in a different way. So rather than just learning the facts about astrophysics, you can now start asking questions. What were the key instruments? How have our ideas changed over time? And as always, follow the money. Who pays for astronomy and why? And I just really got the bug. So I came back, did some more studies, and since then I've worked at the Science Museum and the British Museum, and then I came here just over a decade ago.
That's amazing. So you're, obviously, everyone knows history is the best subject. So it's really interesting that you made that handbrake turn and it's led you here. I really can't get over how wonderful this whole site is. Daisy, can we start at the beginning? So it's 350 years since the Royal Observatory was founded. Why was it founded, and who founded it?
The Royal Observatory at Greenwich was founded in 1675 by King Charles II. And when it was founded, it was Britain's oldest purpose-built scientific institution. So that's quite a big deal. And its founding purpose was really about using astronomy or data from the stars to improve navigation at sea. And this was all taking place against a backdrop of expanding global trading routes and kind of England's desire, alongside other European powers, to dominate those trading routes, and particularly to the West Indies and the East Indies. So it was really hoped that the work of the observatory would contribute to improving navigation at sea, allowing faster and more frequent journeys along those trading routes, and protecting valuable cargoes from shipwreck. And so kind of collecting this positional astronomical data was and kind of creating a detailed map of the stars, because that was really the first step, was really the focus of the work of the first Astronomer Royal, John Flamsteed. He worked on that for at least 40 years, cataloguing almost 3,000 stars, or over 3,000 stars.
Yeah, and it's thanks to Flamsteed's wife, Margaret, that we know so much about his work as well, isn't it?
Yeah, definitely. After Flamsteed passed away, Margaret worked together with Flamsteed's old assistants to publish all of the data that he'd collected in his catalogue, Historia Celestis, and then later on in a star atlas, the Atlas Celestis, and his legacy kind of really lives on today, because we still know a lot of the stars by the names that Flamsteed gave them.
Where the podcast currently is at the moment, we're in the 1670s, 1660s. Europe has, the age of discovery is a couple of centuries old now. There are colonies all over the world. Was there really much more that they needed to learn about navigation?
Yeah, so in this period, so kind of 1670s, it was less about these kind of voyages of discovery or circumnavigations, because obviously, like you've said, those have already taken place in the 16th century. It was more about making those maritime routes between east and west more efficient, making them safer, and being able to dominate those routes, all kind of with an eye on profit from imperial trade.
Let's talk about Flamsteed. This is his house, or next to his house that we're currently sat in. Who was he?
So Flamsteed was the first Astronomer Royal here at the Royal Observatory Greenwich, and that basically means that he was astronomer to the king. He was a self-taught astronomer and an ordained clergyman. And like I said, his task was to plot the positions of all of the stars that were visible from Greenwich. And this was a crucial first step in developing the new navigational methods that would benefit sailors and have a direct impact on maritime trade. Whilst the observatory was being built, he actually first worked from the Tower of London making observations, and then he moved to Queen's House just down the hill in Greenwich Park. I don't know if you were able to visit there today whilst you're in Greenwich.
Visit, but I could see it from the top of here.
Yeah.
It looks like a fantastic building.
It's a really beautiful view down to the house from the top of the hill, even today. But yeah, he moved there so that he could kind of supervise whilst the observatory was being built. And
who was it built by?
It was built by Christopher Wren, who you probably know from St Paul's Cathedral. And so there are a lot of original features that you can still see, especially if you go into the Octagon Room, which is a really kind of special and important room in the observatory's history, because it was where some of the very first observations were taken here. And it was designed with astronomical observation in mind. So you've got these really beautiful floor-to-ceiling windows that give kind of almost panoramic views of the night sky on kind of all sides of the Octagon Room. But the issue with the Octagon Room for taking astronomical observations was that you need to be able to align your telescope along a meridian, which is a north-south line that runs from pole to pole. But because the observatory was built on the foundations of Greenwich Castle, it was obviously not aligned exactly the way that it needed to be. The site and the building was kind of developed throughout time to kind of better accommodate the work that was being done.
Yeah, and I find that quite surprising, because Wren was an astronomer as well, so you would have thought he would have recognised the value of having a good meridian. So that always intrigues me, why they decided to take that shortcut and not do it properly.
Was he just, trying to be cheap and wanted to use the foundations of an existing structure, or did he build it and go, "Oh, I can't believe it! I've been so stupid"?
Yeah, good question. I haven't seen it as a sort of smoking gun, but certainly they must have realised quite early on, because Wren and Flamsteed then designed the Sextant House just a few metres away, and that's really where the sort of the bread and butter observations took place. So they must have realised early on, I'm guessing it was probably to save money, because they were trying to use recycled materials and cut a few corners here and there. So yeah, they were definitely on a budget.
Yeah, and I'm not sure, I can't remember exactly what Flamsteed's salary was, but even though the title Astronomer Royal sounds very regal, I don't think it was necessarily a very well-paid job in itself.
No, I think it was roughly around £100 a year, but certainly quite low level for his level of education and achievement. Yeah.
So, Louise, you mentioned Flamsteed's wife. What was her deal? She outlived her husband, didn't she?
Yes, Margaret Cook, as she was originally. She was a fair few years younger than Flamsteed. So they married around 1690, I believe. And she really seems to have been taken under Flamsteed's wing. He taught her various aspects of mathematics and science. And also she seems to have been a good hostess as well. Samuel Pepys came round for dinner, and in his thank you note, he complimented Mrs. Flamsteed on her good cooking skills. So very sort of talented lady. And then after Flamsteed died, she was effectively homeless, because the house was only here as long as he was in post. So she only literally had lived, I think, about like a month or so to get out. She cleared out everything, because she and Flamsteed had pretty much paid for most things, or else they'd been given to Flamsteed by his patron, Sir Jonas Moore. So all of that incredible instruments, those incredible clocks that Daisy mentioned in the octagon room, sadly they vanished. We managed to get one of the clocks back, and that's now on display in the octagon room. But yeah, I really hope we can find those instruments out there someday.
Flamsteed's successor, I think it's fair to say that Flamsteed and him did not get on.
Yes, so originally it was Edmund Halley. He was actually quite a good assistant. He worked with Flamsteed in the very early days when Flamsteed was doing his observations at the Queen's House before the observatory was finished in 1676. And they seem to have got on at that time, but within a few years cracks had started to appear, and then matters came to a head in 1712 when Halley and Newton published some of Flamsteed's work a little bit too early, before Flamsteed was ready for it. This became known as the pirate edition of Flamsteed's catalogue. And Halley wasn't too popular, and Flamsteed managed to claw back about 400 copies that were published, I think, or about 300 copies in the end, and he burnt them. So there's only a handful that are thought to have survived. And it's quite an interesting, quite a bitter feud between these three great men of astronomy at that time.
And do we have a pirate copy?
We do, yes, in the library. We have Halley's proof copy, so it has got some annotations in it as well, which is really nice. Yeah.
So was he brought in, did Flamsteed give him the proof to be like, what do you think? And then him and Isaac Newton went off and printed it?
It's all a bit murky. I think some papers were given to Newton partly for his work on trying to understand the moon's orbit, which was really crucial for longitude. Some papers were given to the Royal Society, but then also Newton was involved there too. So yeah, it seems that the pirate copy was published without Flamsteed's consent. So yeah, all rather murky.
And were there any, we've all written things in the early drafts, or sometimes stuff we go, why did I write this? This is terrible. Thank God no one's seen it. Were there any major differences between the pirated version and what Flamsteed eventually officially published?
Certainly the final version, the official version in 1725, has a lot more sections, and it covers the whole of Flamsteed's career, right from his work in Derby all the way through to the end at Greenwich. And I think there are also some other sections as well. So Some versions in the official version had these beautiful plates as well, made by Francis Place, that really show us what it was like here at the observatory in those early days. So you've got very detailed sketches of the buildings and the instruments. It's really great to have that snapshot of what it was like here.
So you mentioned longitude. Why was that so important? Was that difficult to work out?
It ties back to the kind of foundational purpose of the Royal Observatory, so navigation at sea, and it's all about being able to find the positions of places on land, but also whilst on a voyage at sea. And so essentially to know your exact location anywhere on Earth, you need to know both your latitude, which is your position north or south of the equator, and your longitude, which is your position east or west of a fixed location. And lines of latitude and longitude are often, seen on maps and globes as if they're real, but they're imaginary lines. And so sailors could find their latitude not easily, because you still needed particular instruments and you needed to be able to do a certain amount of maths, but they could find their latitude at sea by measuring the height of a bright star above the horizon. And by the 17th century, they had a number of tools that helped them to do this, some of which were actually developed from earlier sophisticated instruments that were kind of developed in the kind of medieval Arab world, so kind of representing that kind of flow of knowledge exchange between cultures. But finding longitude was much more complicated. I mentioned that your latitude is your position north or south of the equator, so you have this kind of natural reference point to work with, but there isn't an equivalent for longitude. Obviously today, and well, from 1884 we start kind of officially measuring longitude from through the prime meridian at Greenwich, but that was a decision that was made rather than kind of a natural reference point. Instead, longitude is all about knowing the difference in time, local time, between two locations. So astronomers and mathematicians, they knew in theory that the distance east or west between places was directly correlated to the difference in local time between them. So the further east or west you are from a particular point, the greater your time difference will be. It's the reason that we have time zones today, and it's the reason that if you fly to the other side of the world you get jet lagged, because you're just in a completely different time zone. So yeah, longitude relied on knowing the time at two different locations at the exact same moment, but the technology wasn't really there to be able to put that into practice, especially out at sea. We had pretty accurate clocks, particularly pendulum technology was pretty developed by that time, but it just wouldn't work on a moving ship because the motion disturbed the regular swing of the pendulum. Watches provided another option. They were kind of naturally portable, but they didn't stay accurate over a long period of time, so they weren't really suitable for use across long voyages. So this was kind of known as the longitude problem, the fact that we could find our latitude but not our longitude when we were out at sea. And so in the 17th and 18th century, astronomers, mathematicians and clockmakers all kind of came together to try and find a solution to this problem. And it, like I said before, became increasingly important, or there was a renewed interest in it in the 17th century around the time of the foundation of the observatory, because of the desire to kind of dominate these trading routes, to make more frequent journeys east and west. Ships were carrying valuable resources like tea, spices, timber, porcelain and textiles, and so finding longitude was really about making these journeys more efficient and avoiding shipwreck in order to protect these valuable commodities.
So there's quite a lot riding on finding out longitude. Seems like it's quite an advantage to any country or nation that found that out first. Was there any sort of competition?
Yeah, definitely. So in 1714, the first Act of Longitude is passed here in England, but there are also kind of similar acts that are passed in Spain and the Netherlands and France, and the idea behind the act is to kind of encourage innovation and to invite people to submit proposals to solve the longitude problem, whether it's a new theory, kind of collecting more data, or proposing a new instrument that can help us to measure longitude. And there are kind of three main significant things about the 1714 Act of Longitude. The first is that it offers a series of cash prizes to people who can submit kind of promising solutions, up to the value of, I think it was it £20,000 at the time, which was pretty life-changing. It also establishes a group of longitude commissioners who judge the proposed solutions and are responsible for awarding the cash prizes. But it also specifies that to qualify for any of the prizes, a solution has to be tested on a voyage from Britain to a port in the Caribbean, so kind of really highlighting the kind of significance of those kind of trading routes across the Atlantic to the economy at that time.
So eventually they did crack it. How
Yes.
did they manage that? Who did it?
I mean, it took a long time, and I think, we often kind of debate at what point in time we can say that the problem is solved, right?
So when do you think it was? There was a very knowing listeners. There was a very knowing look there.
I guess it's just because we've been thinking a lot as part of the kind of First Light project that we've been talking about. We're kind of involved in rethinking and reframing our exhibitions, and one of those galleries is the Longitude Gallery. So we've been thinking a lot about how to wrap up the story when we say that a solution's been found. What does it mean?
Absolutely. I mean, this story is so famous and has been told in lots of different ways. Davos Hobel's book, obviously Longitude in the 90s, is very famous. Then we had the Ships, Clocks and Stars exhibition in 2014 for the 300th anniversary of the Act. And now we're starting to look at the story afresh again with different perspectives. Trying to pin down when it exactly was solved. And we often sort of debate, is it when a certain timekeeper was finished, or when it was trialled at sea, or when someone got the reward fund? How do you define that? It's really challenging.
But I think, the moment that's kind of most often cited as when the longitude problem is solved is with the fourth timekeeper that was developed and put out by John Harrison, which we're sitting next to right now. So John Harrison was a carpenter from Lincolnshire turned clockmaker, and he read about the rewards that were on offer in the Longitude Act, and he kind of dedicated his whole life really to develop a timekeeper that would work out at sea. And we're looking now at kind of a series of his 4 famous prototypes, which are
they get incredibly more and more elaborate and larger, and then suddenly
they change.
It's like a very bulky pocket watch.
Yeah.
So what was how long did it take him to go from Harrison 1 all the way to Harrison 4?
Oh, so when was Harrison 1 completed?
We usually say about 1735.
Yeah.
So it probably took about 20
years. Or even probably closer to 30 years, because H4 was trialled in the early 1760s. So, probably almost 30 years. So really his whole life, similar to how Flamsteed was working on his thing for his
and he was
whole
obviously thinking about it from early on in the 1720s, because we know that he came to the observatory in the late 1720s and met with Halley, our good old friend Halley again. Halley couldn't really appraise the idea himself, but he knew a man who could, George Graham, who was London's top clockmaker of the time. So he told Harrison to go and have a chat with Graham and get some advice. And apparently the two men chatted for about 10 hours or so. Harrison stayed for dinner. But eventually Graham was convinced and he agreed to stump up some cash himself. And then he also introduced Harrison to the London clockmaking community. And that's really where Harrison could get that sort of expert knowledge to help him develop his prototypes.
And in creating his prototypes, he was really trying to tackle the three main challenges with taking a timekeeper out to sea. And that's motion, as I mentioned before, the reason why you can't use a pendulum out at sea. And another reason was temperature change. So as you're kind of on a ship passing through different regions of different climates, that kind of can cause the different parts to expand and contract. And then there's friction as well. Obviously, you can see, because we're running H3 at the moment, that there are a lot of different moving parts in all of these prototypes. And for those parts to stay moving over the course of a long voyage, they need to kind of stay lubricated. There's issues with friction that he's trying to overcome. Usually with a clock, you have to stop it after a certain amount of time, oil it and restart it. But if you're out at sea and you don't know what time to restart your clock onto, you kind of just need to make sure that it's running consistently the whole time. So motion, temperature and friction were really the three main things that Harrison was trying to tackle along this clockmaking journey.
Yeah, no wonder it took like a whole, hundreds of very, very smart people so long to even get close to it. That's so many things to keep in mind, especially when your knowledge about those factors is itself still growing.
And I like the fact that even though they're essentially metal work, you can still see Harrison's expertise as a carpenter coming through. So, for example, he chooses certain woods for certain parts.
With H1, we can see one of the ways that he's trying to tackle this issue with friction. He decides to use a wood that's called lignum vitae, which is a tropical hardwood, which is naturally oily, so it kind of reduces the need to stop the clock for oiling. And I think equally you can see Harrison was also a keen musician. He was interested in music, and I think there's something about the instruments that kind of, well, they're called instruments, so clues in the name a little bit, but yeah, they kind of speak to the kind of musical knowledge or that kind of interest.
They look like pieces of art, really. They are really very, they are stunning.
Yeah. Yeah.
And I know in Harrison 4 it looks like gems.
Yeah.
Are they just for decoration, or like?
This was another way that Harrison was trying to overcome the problem with friction. So he uses a number of jeweled bearings in H4, diamonds and rubies. And because of their hard, smooth surfaces, they work to reduce friction, the movement of the clock. But with H4, he unfortunately couldn't reduce the need for oiling completely. So that's part of the reason why we don't run H4 in the gallery. H4 still did require oil to run. I mentioned before that to qualify for the prize, any proposed solution had to be taken on trial on a voyage from Britain to a specified port in the West Indies. And H4 was first trialled to Jamaica, where it performed really well. But the Board of Longitude, it eventually became the Board of Longitude, this group of longitude commissioners, they decided that they wanted a second trial. And in 1763, they organised for H4 to be trialled a second time to Barbados. And the person responsible for that trial was Neville Maskelyne, the astronomer Neville Maskelyne, who again eventually becomes Astronomer Royal of the ROG. And I think this is another kind of really important link between the longitude story and the history of empire. When Maskelyne is on Barbados, he writes a letter back to his brother where he mentions kind of the proliferation of sugarcane on the island. So Barbados was kind of one of the main producers of sugarcane, which is harvested through the labor of enslaved Africans. So yeah, he's really taken by the number of sugarcane plantations that he sees on the island, and he writes to his brother about that. And the other kind of reference that I've found in looking into this story is that when H4 is being carried over to Barbados on HMS Tartar, they reference kind of that they spoke a ship that was bound from Africa to Jamaica. They don't, exactly specify what ship it is, but I think what it really reminds us of is that a lot of these methods are being tested on routes that are really integral to the transatlantic trade in enslaved Africans. So it's there are these kind of hints to those links in the archive, but and we're really just kind of starting to pull the thread on that in what we're doing now. But there's a lot to kind of unpick there.
So Neville Maskelyne, like you said, he does become Astronomer Royal. What is his period in office like?
Yes, so he's appointed Astronomer Royal in 1765, and he's tasked by the Board of Longitude to create this new publication called the Nautical Almanac. And the idea is that this is essentially a book of data that you take with you out to sea, and you can use this to work out your longitude using the moon. So it's a bit like having the observatory or an astronomer in your pocket, and it gives the predicted position of the moon every day, every 3 hours for the year ahead. So really impressive. So Maskelyne starts his observations. He has this very nice observing suit made of wool, silk and linen to keep him nice and cosy. He's got a little jacket and then a pair of leggings that go right over your feet to keep you nice and warm.
It sounds like a onesie.
It is, pretty much. Yeah, a onesie or even pyjamas. It's got a bit of a stripy pattern going on as well. So a really lovely object. Currently not on display, but we're hoping to get something out similar in the next few years. And he would have worked alongside an assistant, so they would have been out in the freezing cold, sat at the telescope that's aligned with the meridian, this north-south line, timing the stars as they cross that line and using all of that information. Now, as you can imagine, there were a lot of calculations involved, so very smartly he decided to outsource the work. And so thanks to his contacts, he had a network of mathematicians around the country. So he would parcel up the manuscripts, post them out, send them off to be checked by people working in Cornwall or Shropshire, different places. One of them was, in fact, a lady, Mary Edwards in Ludlow. So this was very much a cottage industry that even women could get involved with as well. So Maskelyne kind of oversaw that, pulled together all the work, and then got the Nautical Almanac published. And this really helped sort of cement Greenwich as a place of reference, because now when you're out at sea, you're doing your observations, doing your calculations, you're constantly thinking, where am I in relation to Greenwich? And that would really sort of contribute to the decision to make Greenwich prime meridian of the world about a century later.
And something that honestly only struck me when I was here and I was on site is that there's more than one meridian, which suddenly I was like, of course, that's what prime means in prime meridian. So why are there's I think there was 4 different meridian lines here at the observatory. Why is that? Why there's different places?
Sure. So as always, a new astronomer wants to set up their own new meridian. So a meridian is fairly arbitrary. As long as it goes from the north to the south poles and through your position, you can use it. So Flamsteed had his meridian, and then Halley came along, set up some new instruments, set up a new meridian a few metres away, of course. And then James Bradley, the third Astronomer Royal, said, I know, I can do better. New technology, a new improved meridian, and then so on, and then culminating with the meridian defined by the meridian circle designed by George Biddle Airy, the 7th Astronomer Royal. This was bigger, better, grand Victorian engineering, but essentially the same principle, still aligned on a meridian, that north-south line, and still timing the stars. So it's kind of like an evolution. I think of it as being a bit like iPhone 1, 2, 3, 4, just different generations of the same thing.
And you can definitely see the change in technology just looking at it. The Flamsteed's telescope is, still a wonderful creation, but then you compare it to 4, and it's enormous. It's amazing.
Yeah, I think Aries transit instrument, the telescope, for a lot of people it takes them a while to realize that it is a telescope, because it looks almost like kind of a piece of railway engineering. It's really...
Yes, so if you're standing on the prime meridian taking your classic selfie photo, if you look through the glass, you can actually see this big black telescope that's supported by 2 stone piers, and that's Aries transit circle.
Maskelyne, like I said, used a bunch of human computers. Was he quite, progressive for his time, at least when it came to dealing with women in science?
I would say so, yes. Certainly he worked closely with Caroline Herschel, sister of William Herschel and an astronomer in her own right, discoverer of 8 comets. And it was thanks to Maskelyne that her work was seen and also published by the Royal Society. So he really sort of championed her work. And at one point he even described her as my worthy sister in astronomy. So you get the sense that he really values her as an equal.
And that's, I imagine, unusual for the time.
It certainly seems so. I mean, Caroline herself is quite deferential and sort of, is this okay? Am I good enough? But I think Maskelyne really seems to endorse her work, and he certainly persuades other people to support her as well. So it seems unusual, but very welcome.
I want to jump ahead to the 7th Astronomer Royal, George Airy. What makes him so interesting? What was his main contribution to the observatory that we're currently sat in?
Yeah, so George Biddle Airy was appointed in the autumn of 1835, and he really sort of transformed the observatory's scope and work. And in some ways we have to go back a little bit just to sort of find a bit of context, really. So during the 1820s, we had John Pond as the 6th Astronomer Royal. Pond was a really good observer. He focused very much on doing all the observations. He wanted the best instruments. But he was really struggling because since 1818, the observatory had come under the remit of the Admiralty, and they wanted good value for money. So they wanted the observatory to do work that was advantageous for them, namely testing and rating chronometers, the descendants of Harrison's timekeepers that became this sort of gadget that could be used to work out your longitude at sea. So Pond was a bit sort of bogged down, really, by all these demands from the Admiralty, and he resigned due to ill health, but some people speculate that maybe he was pushed out in 1835. But nonetheless, George Biddle Airy certainly seems to have been the best candidate. He was the rising young star in astronomy at the time. He'd graduated from Cambridge in 1823 as senior wrangler. So this is the top-rated mathematics student. So he had the best academic credentials. He'd published papers on optics, planetary orbits, and also experiments to measure the density and the shape of the Earth using pendulums. So he had good academic credentials. He also had good sort of practical skills in that in 1828 he'd been appointed as director of Cambridge Observatory. So he knew a lot about how to organise people, how to commission new instruments. And you can certainly see those threads coming through when he comes to Greenwich and starts to apply sort of similar themes as well. So he arrives in 1835. He's joined at Christmas by his wife Rashada and their 3 children at that time. The couple would go on to have 9 kids. And that's partly why we have these extra rooms added onto Flamsteed House, because they literally just needed more bedrooms for the kids and the nursery maids and the governesses and everyone. So he came to the site and he really sort of reorganised things, employed more staff, commissioned new instruments, including that Airy transit circle that would become such an important instrument later, and really started to expand the remit of the observatory.
I just think what an amazing place to grow up as a child. You mentioned the 9 children. I think a lot of people maybe don't realise immediately when they come here, but it was a place of work, but it was also, where the Astronomers Royal and their families lived.
Absolutely, yeah. We have, there's a little bit of graffiti in the wall where the kids have sort of scratched their names into the brickwork, just like all good kids. There are stories of, I think 2 of the boys were caught running across the top of the roofs where the meridian hatches were. And there's also a really lovely little sketch of when the time ball blew down in a storm into the courtyard. And so one of the boys, I think it was Hubert, actually made a watercolour.
Just ordinary observatory
Yes,
sounds.
I was just about to tell listeners that is the price of being surrounded by clocks everywhere. So you mentioned that the Admiralty wanted their value for money. Did he give them value for money?
Yes, I think so. So in addition to the chronometer testing, so checking these chronometers against the accurate clocks set by the sun and stars before they were issued out to sea, Airy also instigated a new program of taking daily magnetic measurements. There'd been quite a few scientific voyages organised by the Admiralty in the 1820s, 1830s up to the poles, and it was noticed that sometimes these magnetic compasses behaved a little bit strangely. Sometimes the needle dipped down or it went a bit crazy. So people were really trying to understand magnetism more, both for practical purposes but also from a theoretical point of view. What is magnetism? What is the Earth's magnetic field? So at that time, there was this global network of magnetic observatories called the Magnetischer Verein, organised by scientists in Göttingen in Germany, and Greenwich became part of that network. And so the assistants would take measurements every 2 hours of these very sort of finely balanced, delicate magnetised needles that were positioned in a wooden building known as the Magnet House, and deliberately made of wood to avoid any interference. But as you can imagine, this was a huge sort of drain on Airy's resources, trying to allocate manpower every 2 hours to take all these measurements. So he set up a competition, I guess a bit like the Longitude Act. It's a common theme here. And it was won by Charles Brooke, a London surgeon, who realised that you could actually create a photographic method of automatically recording results using a combination of lights and mirrors to record a trace on light-sensitive paper. So that helped free up some staff. So then Airy also instigated regular measurements of the weather, so temperature, air pressure, and so on. Airy was a bit sceptical about the weather readings. Meteorology was going through a bit of a sort of transition phase at this point. Traditionally, it had been seen as a bit of a folklore thing, only something that shepherds or fishermen or gamekeepers would be interested in. We've all heard those proverbs, red sky at night, shepherd's delight, all of that. Is it really science? Well, thankfully, in this period, people were starting to develop new theories in mathematics and physics, and starting to realise that temperature and atmospheric pressure were all related to these theories. So collecting data for meteorology became really important as well.
That's fascinating. If we jump ahead to the 20th century, what happens with the observatory then?
Yeah, so 20th century, there's much more focus on photography. So this starts really in 1890 with the appointment of 4 ladies known as the Lady Computers, and it was their job to systematically photograph the night sky, develop the glass plates, and then measure these star positions very accurately. And this was because the Astronomer Royal at that point, William Christie, had already committed the observatory to take part in this massive international project, the Carte du Ciel, the map of the sky, where about 20 observatories all around the world were going to photograph the night sky and then knit together all their work into one giant photographic atlas. Now, rather optimistically, they thought they could do this in 5 years. But unsurprisingly, it was much more labour-intensive, and so people realised that actually we could use women to do this work. Now, there was a bit of a variation in approach. For astronomers in Mexico, they just got their daughters to do the work. At the Vatican Observatory, they recruited some nuns to do the work, but thankfully here, Christie was a little bit more enlightened and actually took on some Cambridge graduates. Graduates, they were women who'd done the mathematical tripos, but they couldn't get degrees. Yeah, it wasn't until 1948 that women could actually get degrees, which just seems unbelievable, but they came here, they worked incredibly hard. 2 women in particular, Alice Everett and Annie Scott Russell, later Maunder, did an incredible job. You would have thought that maybe that would have kick-started a long-term career in astronomy, but sadly not. After a few years, they both had to leave for various reasons. So But photography remained a really crucial part for the observatory's work for the next few decades, right up until the 1930s, when the atmospheric conditions here just became sort of unworkable. There was sort of smoke pollution from the nearby factories, there were vibrations from the turbines at the power station, and then you had the electrification of the railway, which is completely hopeless if you're trying to do magnetic measurements. So yeah, it really was time to leave, and certainly by the 1930s, people were starting to talk about moving away from Greenwich.
I had no idea. I'd never even considered the fact that obviously the city changing around Greenwich, we're in the middle of an oasis of greenery, but it's still London. So of course it's no longer environmentally sound for the work they wanted to do. Where did they end up going?
So initially they moved to Hurstmonceux down in Sussex. They had to wait because of the Second World War that kicked in. But after the war, they certainly started moving sort of department by department. And they stayed at Hurstmonceux for several more decades, right up until 1990. I've met some of the astronomers who lived and worked there, and you really get this sense of a very vibrant community, because the astronomers, they lived and worked there, they lived in the same roads, they knew everyone, there were marriages between the sort of men and women, they went to each other's weddings, christenings, they had a sports and social club. So it seems like quite a sort of a magical time to be an astronomer at the Royal Observatory. But by the 1990s, there were bigger projects elsewhere, so new telescopes were being built in Chile, Hawaii, the Canary Islands, and it was just cheaper and easier to send British astronomers there rather than maintaining an observatory under our grey, cloudy skies. So the observatory shut in 1990. It moved to Cambridge, but the writing was really on the wall, and by 1998 the whole thing had closed.
But it's open now as a museum. How did that transition come about?
So the transition came about in the 1950s, and it was quite a gradual process. At first, it was only Flamsteed House that was open to visitors, so you could go up into the Octagon Room and see some of the historic instruments there. And then gradually the site was redeveloped. There was quite a lot of damage from the Second World War as well that had to be fixed. And then some of the buildings started to open in the mid-1960s, and that's when it really starts to become a museum. You get some great photos of ladies in miniskirts from the 60s, sort of in the Meridian Courtyard, and then you got all the flares in the 1970s, and then the big hair in the 1980s. So really fascinating to see sort of all the different trends over the decades.
Well, hang on, so were people getting, not selfies, but photographs of themselves on the Meridian line for decades?
From the 1960s onwards, yes. Yeah.
I love that that's a tradition. I'd never even thought about when the first one would have been taken, but of course, like when easy photography was available.
Yeah, it really becomes sort of the main thing to do while you're here is get that souvenir photo, and we're always trying to encourage people to look through the glass and see the telescope. That's where the action happens, but everyone just wants their photo.
They want their picture on the line. Was it in the 1960s then that they put the kind of physical line in the courtyard, or did that come later?
I believe so, yes. I mean, from a technical point of view, you don't need a brass strip in the ground to show you where the meridian is. You're doing it all by the stars. But yeah, it seems to have been added in as some museum furniture, but it's a great piece.
Yeah, it's whoever had that idea, brilliant idea, because people are still standing on it today. So what kind of legacy can we see from the Royal Observatory? We touched on so many different aspects of the developing ideas around science, meteorology and magnetism and obviously timekeeping. We're surrounded by clocks. So what's the legacy of this particular observatory for all of those things? A nice, quick, easy, short question.
Well, certainly for us here at Greenwich, I think our legacy is very much science communication and sharing our love of astronomy with the public. And you can really see that in many of the astronomers throughout the ages. I mean, certainly in the 1800s, people like Edwin Duncan and the Maunders, some of these assistants, they were writing popular astronomy books. They were really sort of the celebrities of their day and really wanted to share their love and passion for the subject. And we're really sort of continuing that today. On a more technical level, I think you can still see echoes of Greenwich through organisations such as the UK Hydrographic Office, which still produces the Nautical Almanac. It's known as the Astronomical Almanac now, but I believe that ships are still required to carry a copy just in case of GPS failure, so it's still important. They also calculate all the times for sunrise and sunset, for calendars, the date of Easter and all that kind of thing. Then obviously you've got the Meteorological Office, the Met Office, which is a separate organisation, but there are certainly some crossovers from that period. The magnetic data is still collected today by the British Geological Survey, which has several locations around the country. And then, of course, time distribution. This is critical now for the financial sector, for the military and so on, and that work is continued by the National Physical Laboratory in Teddington. So yeah, there's still these sort of echoes of Greenwich throughout our lives today.
That actually reminds me of a question I wanted to ask. When did the whole idea of Greenwich Mean Time become, almost like the default for the whole world?
It's got quite a long gestation, really. I mean, it sort of starts with Flamsteed and his work of trying to create this average or mean time as seen by an observer at Greenwich. And initially, it's only really useful for other astronomers and navigators. It's adopted by the people working on the Nautical Almanac in the 1830s because now more people are using chronometers. So it's much easier to work with the almanac if it's in Greenwich Mean Time. The crux really seems to come in the 1840s with the advent of the railways, and particularly in 1847 when the railway companies decided to adopt Greenwich Mean Time across the whole network. Previously, they'd used the local time at their depot, so Manchester time, London time, Falmouth time, which could vary by about half an hour across the country from east to west, which would just be an absolute nightmare if you've got to change trains in Rugby or Southampton or somewhere. So it just made a lot more sense to all use the same time, and I guess that gradually sort of drip-fed into factory time, school time, commercial time. I mean, technically, it wasn't UK national time until 1880, so quite a long time after it had already been implemented by the railways. On a more global perspective, it all goes back to that conference in 1884 when they decided to adopt the prime meridian defined by the Airy Transit Circle as prime meridian of the world. There was also discussions about creating a universal day that began and ended at Greenwich, and this became a way of comparing times across the world with greater ease. So that's really when it starts to take shape internationally.
Louise, you as somewhat recently published a book, History and Objects. Can you talk briefly about why did you write that book and what was the process behind actually writing it?
Sure. So 2025 was our 350th anniversary, and we wanted to produce some sort of commemorative volume. I think, gosh, how the heck do you condense sort of 350 years into one book? Well, I think for me, I was kind of inspired by my previous work at the British Museum. I really liked Neil McGregor's History of the World and 100 Objects. And I just started thinking, maybe I could do something similar with the Royal Observatory's collections. And it just started to take shape from that, really. And I really wanted a good spread of objects. So you'll find everything from the classics, so these beautiful Harrison timekeepers, the Great Equatorial Telescope, and all the favourites, alongside a few sort of more unusual choices as well. So, for example, I wanted to convey more of those domestic stories that we mentioned. So one of the objects is Neville Maskelyne's wife's wedding dress. It's a beautiful purple and silk brocade dress. We've also got family photos, and a rather sort of poignant item is a catalogue of double stars that was produced by Robert Jonckheere. He was a refugee astronomer. He was from Belgium, came here during the First World War. Poor man had to walk across fields to get to Boulogne, to get a boat across to England and then get a train up to London. But he and his family stayed here with the Dysons. The Astronomer Royal was Frank Dyson at the time. And it's just a really lovely story of sort of solidarity and friendship and support during a really atrocious time in our history. So really inspiring. And then the book takes us all the way up to atomic clocks as well. So a whole mixture of things, and I've really enjoyed writing it.
So now comes the most possibly difficult question for two curators from the museum. Speaking of objects in this fantastic collection, what are your favourites? Daisy?
Okay. This one is pretty easy for me at the moment. Obviously, there's so much to choose from. But at the moment, I've been looking into, and I'm just really taken by a collection of 9 wall hangings on astronomical themes that we have that were produced by the Working Men's Educational Union in the Victorian period. So the union was like a philanthropic organisation that aimed to kind of uplift the working classes through education, by organising mutual instruction classes, by promoting lending libraries, and by creating these kind of really beautiful diagrams to accompany lectures on all different subjects. But the ones that we have in our collection are all on astronomical themes, and they kind of represent a time in the 19th century where education in astronomy was becoming kind of more widely available and more inclusive, and there were kind of these huge efforts being made to kind of bring working people into conversations about astronomy and kind of all of the really amazing discoveries that were being made. And I really like them because I think that they have this kind of value in terms of their social history, that they kind of really capture a moment in time where astronomers were learning lots of new things about the sun, for example, and communicating those new findings to audiences, but also because they're so beautiful. They're like works of art as much as they are kind of artifacts of scientific communication. So I've been doing some research into these objects with a colleague, Maya Wassell-Smith. She's a curator in the art team. And yeah, we're working on a piece of research that kind of looks at these objects through the lens of scientific communication, but also art history. So
really interesting.
Those are my favourite. I don't know if that's cheating because there are 9 of them, but I'm seeing them as a
object. Are they on display or are they?
They're not.
No.
So it's quite difficult to put. They're textile, so they're printed lithographically on cotton, and this was to avoid really heavy taxes that were being placed on paper at the time, but also to make them kind of robust and portable for lecturers who are travelling all around the country. But because they are textiles, that it makes them quite difficult to put on permanent display because they're really sensitive to light. So they are in storage, but you can go to our collection centre out at Kidbrooke and you can order objects that are not on display to be seen. But we are working towards what we call a spotlight book on these objects. So they're easily searchable through collections online if you're interested in seeing pictures of them. But also, we'll be hoping to put out some new information on the wall hangings in the form of this spotlight book soon. So
that'd be really cool. Looking forward to that. And senior curator, what would be your chosen one?
Oh, that's a tough one. I mean, just to follow on from Daisy's choice, I often think of those wall hangings when I'm out and about doing lectures and tours, and now we just have like a USB stick and some PowerPoint slides. But for your guys, you really had to literally carry your presentation around with you in these hangings.
I mean, you still could do that if you wanted to really.
I could try, couldn't I? Yeah. It might be a bit difficult for 40 slides, but yes. For me, my object is very plain and very boring, but it is actually quite fundamental. So this is a piece of black wire that's been bent into a fork with 2 prongs. It looks a bit like something you'd use in the garden or on a barbecue even. It's quite vicious looking. But this is a spider fork, and this was used for encouraging spiders to spin their silks or their threads around the prongs. And it might seem a rather curious choice for an observatory. Why on earth do you need spider silk?
That was going to be my question.
Yeah. So the idea is that when you're looking through the eyepiece of your telescope, you're tracking your star, but if you imagine that circular view, the star could be anywhere. It could be top left, bottom right, in the middle, on the side. How do you accurately define exactly where it is in that field of view? So astronomers started putting in these vertical lines so you can actually count or time as a star crosses each line as it appears to move from east to west. And they tried various materials, metal wires, silk, thread, cotton, even human hair. But partly by accident, they found that actually spider silks are the best because they don't bend or shrink or snap too easily. They're quite sort of robust and don't change if the temperature varies or if the pressure varies. So that's why spiders are effectively an astronomer's best friend. And this fork was really crucial for collecting those silks. So you stand on a stool, don't try this at home, and then rotate the fork and let the spider sort of drop consecutively. And then eventually then you can leave the silks to dry out, and then you can extract them and use them in the instrument. And in one of the inventories, it actually says that there's a box of cobwebs next to the telescope, just in case one of them does snap. So yeah, really, really helpful creatures.
This may be the same actually, but what's the most underrated object as far as you can, in your judgment? Like, people come to the Royal Observatory and they see the massive telescopes and they see the fabulous clocks. What's something that, when people come here, which they absolutely should, what's something they might mistakenly walk by and they really should take another look?
Kind of staying on the same theme of kind of popular astronomy, Victorian Britain, there is a really lovely object that's on display in the apartments, so like part of the building that we're in now, which is a collection of 32 constellation cards that was part of this set called Urania's Mirror. And essentially, these were kind of printed, coloured cards showing the different constellations, and they had the main stars kind of pierced with holes. And the idea was that you would hold them up to the light, and the light would shine through and kind of give you this sense of what the constellation should look like in the sky. So this was, usually used within like a middle class home, maybe as a kind of an educational aid for children. And I think that they're pretty underrated, just in the sense that they're quite small, and they're not it's not necessarily an example of like scientific instrumentation, but it's kind of an example of how maybe ordinary people might learn about astronomy, or how they might interact with them in kind of this kind of personal, intimate moment. So I really like those. What about you, Louise?
Oh, that's tricky. I mean, yeah, great choice with the constellation cards. I totally agree. And there's just, the colours in them are so vibrant as well. When you see all the creatures like Cancer the crab and so on, it's great. For me, it's kind of right opposite me just here, actually. It is, in fact, the Nautical Almanac, because it is just a book of numbers, and it's so easy just to walk past. And I have to say, they're in competition because we've got these glorious, shiny, beautiful, mesmerising Harrison timekeepers right opposite them. So, of course, you're naturally drawn to them. But for me, the Nautical Almanac is just such an amazing piece of human achievement. The fact that people had to do all those observations in the freezing cold, do all the maths, pull all that data together, get it printed, published, and then people were relying on this thousands of miles away in the middle of the ocean. I think that's pretty cool, just for a book of numbers, actually.
Both fantastic answers. So what's next for the observatory?
So you mentioned before I am the Curator of First Light, which is maybe a bit of a confusing job title, but First Light is the name that's been given to a really big and exciting project that we're undertaking at the moment in celebration of our 350th anniversary. First Light is named after the moment that a telescope is first used to view and record the night sky. So that's where the phrase comes from. And the project will see just the complete transformation of the Royal Observatory Greenwich. So that will include preservation of our historic architecture, the revitalisation of our gallery spaces, both on the history of science and also some brand new galleries, interactive galleries on contemporary science, but also, excitingly, the development of a brand new public programme based around the heritage of our site and its themes. So as curators, we are busy working away on the exhibition side of things, but we're a really big team, including like our partnerships team, designers, architects, and astronomers. So I'd really recommend that people come and see us before we close, get a sense of what we're like now, and then come back to us again once the project is complete and see everything that we've been working on.
Yeah, I mean, it's a really nice opportunity just to re-examine these stories again and bring in different objects and put some new objects on display as well. Some of the objects that we're proposing have never been displayed before. So, yeah, really excited at this opportunity.
This has been so interesting to hear the passion and enthusiasm you both have for it. Dr Louise Devoy and Daisy Chamberlain, thank you both so much for this, and I will 100% recommend people visit the Royal Observatory. It is absolutely worth the hike up the hill, which no one warned me about before I got here. Thanks for listening to this panel with my guests, and since it was kind of their house, my hosts. Dr Louise Devoy, Senior Curator at the Royal Observatory Greenwich, and Daisy Chamberlain, Curator of First Light. I cannot recommend enough a visit to the museums at Greenwich next time you're in London, especially the observatory, and particularly if the weather's nice. Charles, Flamsteed and Christopher Wren really did pick a great spot. When you go, see if you can pick out some of the exhibits we talked about today, and of course, get your picture taken on the Prime Meridian. Thank you to all of the staff at Royal Museums Greenwich for arranging this interview, to my entire Patreon House of Lords, and to you for listening.